Good morning, good afternoon, everyone. Welcome to Module 4, Session 1, Deep Learning in the Industry. Our speaker today is Sanyam. So make sure you drop your questions in the Q&A box. And with that said, I'll just hand it over to our speaker. Enjoy.
Thanks, Franklin. Hello, everyone. This is Sanyam here. I'm going to be talking about deep learning. This is session one of two sessions. This one is aimed towards deep learning in the industry. Broadly speaking, I'll be introducing you to some jargon. I promise not too much. The goal, as received from the feedback, is to give you a broader understanding of where deep learning is being used and maybe help you get as excited about deep learning as I am. So just as a reminder, this is module 4 and 3 modules have already been covered. To remind you, module 1 was about AI transformation journey, followed by demystifying artificial intelligence. Module 3 was an intro to machine learning where we got to know about a few algorithms, generally speaking, also what are the different categories inside of machine learning. And today we are at module 4, which is deep learning foundations. As in heads up and as a spoiler, deep learning is a very wide field. So this may not be able to cover the complete breadth of the field, but the goal is to cover some foundations and in this session maybe explain to you why should you care about deep learning, what is even deep learning. And in the next session that will happen 2 days from now, if you're watching live, we'll delve more into theory and maybe talk a bit more about the recent developments. As a secondary reminder, this is part of the AI Foundations course. The Machine Learning Foundations course, which will follow this one, will be more technical and will include more applications, will include more technical depth. So please stay tuned for that one, which will start after this course concludes. So what can you expect from this session? I'll start by talking about what is deep learning. Maybe start with a very high level definition, followed by recent developments in the field. Why is it important now? Where is it being used in the industry? And maybe analyze some use cases along the way. So, what exactly is deep learning? I'm sure you've heard the term across even smartphone keynote presentations today. It's literally being used across many apps. Whenever you even surfing the internet, the content that's being surfaced to you, you may or may not be familiar with the fact it's being surfaced to you via deep learning. Or even when you take a picture, the reason your cameras are getting better, some amount of machine learning, specifically deep learning on the mobile phones, is being applied. So let's start with maybe breaking down the field. We've talked a lot about artificial intelligence, machine learning in the previous sessions. Just as a reminder, this is the overview of the field. AI surpasses all of these wide variety of topics. So contrary to prior beliefs, deep learning isn't separate from machine learning. It's actually a subset of machine learning. So the algorithms aren't separate per se from machine learning algorithms. They're just a subset of it. And these aren't disjoint from reinforcement learning or computer vision or NLP as well. These lie at an intersection. Sometimes they overlap, sometimes they're different. And the word deep learning, the word deep in deep learning comes from deep neural networks. Deep learning is an effort to replicate neural networks, to replicate human brains. That's where the name originates from. And I'll also talk a bit about how exactly does an artificial neural network, an ANN as you call it, a single neural network, how does it even work? So to start off with some jargon, I promise this won't be as jargon heavy, but these are a few important terms to help you get a grasp of the thing. So as I said, deep learning is based on an attempt to mimic human brains. As researchers have analyzed machine learning, and through the years, the goal of AI, the goal to create artificial intelligence is to make an effort to mimic human brains. ANN, artificial neural network, note for this presentation, NN, ANN, or neurons. all refer to the same thing, which is artificial neural networks or neurons. And these are the foundations of deep nets. What is a deep net? A deep net is created by a large sequence of single neurons. So, similar to how your brain has a single neuron, if you combine many of artificial neurons, you get a deep neural network. And these work on something known as universal approximation theorem. So, to the right, if you pay attention, is an image of a neuron inside of a human brain. And below that, under that, is an image of a artificial neural network, a simple perceptron or a single neural cell, artificial neural networks, single cell. If you roughly draw some parallels, you may notice that this can be seen as a way to mimic the brain. There are a few inputs going into the perceptron, the single neuron, which are similar to dendrites. There's a cell body where some computation happens. So inside of human brains, which is made up of neurons, there are dendrites which take a signal to a single neural cell. There's the cell body, the central nucleus, where some computation happens, and axon or terminals where these signals are carried towards the next neuron or are simply passed on inside of your brain. And if I may argue, your brain is simply a collection of neural networks, single neurons. So in our artificial brain or in our artificial neural network, what we're doing is we're collecting a set of inputs, we're passing it to the body of our artificial neuron, where we do some mathematical functions to express in simplified words. After that is done, what we're doing is a bunch of matrix application, a bunch of matrix multiplications, additions, divisions, something like that. After performing that mathematical function on whatever input there is, we produce an output, which is further sent inside of the neural network. And a large collection of these forms a deep neural network, hence the word deep. There are different definitions to deep. Most people would agree. Most people would agree that when you have more than 2 layers of these neurons, you get a deep neural network. So this works on something known as universal approximation theorem. And this is a mathematical theorem which states that any function that is similar to neural networks can approximate any problem to any level of desired accuracy. So given that you can state your problem in the format of a neural network, you will be able to approximate any problem or approximate your neural network towards any problem to a certain level of accuracy. I'm going to pause my presentation and hop over to a website. This website is neuralnetworksanddeeplearning.com. They have a really nice visual that explains this. So please do check out the website. This is the output of your neural network along a 3-dimension. So this is a single neuron, which along with the function, which produces the star function. Now, any input, any mathematical function can be represented as a collection of these. So once you're able to add plenty of these produce such a surface. And you can imagine as we keep adding these, as we keep generalizing this further, artificial neural networks should be able to generalize to anything in general, or should be able to predict, understand, or create an AI. That's the promise of AI. That's the promise of deep learning. So to remind you, why am I even talking about these? Neural networks work based on this theorem. It's a theoretical theorem, and it states that these are able to approximate anything that can be represented as a mathematical function in their format. Part 2, now I'm going to jump into applications and present a few selected applications where deep learning is being applied. These won't cover anything. everything, but these will sort of give you a taste. And I'm skipping some theory so that all of us can get as excited and maybe understand where deep learning is being used instead of first getting boiled down by the jargon, because there's a lot of theory inside of deep learning. So if you don't get a complete understanding of maybe all of these applications, that's fine. I hope this gives you some taste of where this field is being used, or where is it being applied today. So I'll talk about 3 or 4 broad applications. One of them is computer vision. Wherever we use some algorithms and try to apply those to images or videos, that's known as computer vision. So this could include understanding images. I'm not sure if you've seen the recent smartphone keynotes, but there's a lot of research that goes into understanding which image will be the best one that's picked by your phone. So whenever you even clicking a picture, you don't have to worry about focusing on yourself. Your camera goes ahead, figures out where you are in the picture. It applies a focus on your face and takes a beautiful picture of you, hopefully. The reason it's able to do so, there could be many algorithms. One of them is definitely deep learning. On your phone, some algorithm is running that's helping the phone understand where you are in the picture. And if you've seen on social media, that's one of the reasons how it's able to tag you in your photos as well. You could use this to classify as well. Your gallery now has your favorite friends tagged into albums. That's image classification happening inside of your phone. And to remind you, this is again an application of deep learning that's running inside of your phone. Or if we look at the GIF, it's also being used in self-driving cars. And these different colors inside of this short video or GIF highlight different objects. So the dark blue colors highlight cars. The light pink color highlights the footpath. Green highlights trees. And gray highlights poles. So you can understand when a robot is trying to navigate in an environment, it needs to understand its surrounding. Or even not for a robot, for your own processing purposes of videos or images, you'd want to segment every individual part inside of a video or image. So that's what's going on in this video. For a car, it's important to know where to drive and where not to drive. So a self-driving car is absolutely not allowed to drive on the pink colored segments, which is the road or the footpath or the sidewalk. And it's absolutely not allowed to be in a proximity of the pedestrians. And this is one of the ways through which the system can understand its environment. Let's talk about natural language processing. I'm sure you've seen these chatbots pop up on the right. There's H2.ai bot. If you ever navigate to our website, this will be a pop-up that'll show up in the bottom right corner. Some of these, especially the ones where you get to chat and the bot understands what you're talking about, they run sentiment analysis models. Wherever in this presentation I use the word model, it can refer to a machine learning algorithm or a deep learning algorithm, broadly speaking. So models are deep learning models or deep learning algorithms that are being run. So whenever we interact with the chatbot, with a conversational AI, broadly speaking, we're talking to a bot that's running on the website, or you're interacting with an interface that connects with the deep learning algorithm that tries to understand what you're talking about. If you've noticed, these have gotten better with time. They're able to understand and appreciate the context better. They're getting lesser frustrating with time. Whenever you trigger your Alexa, not to trigger anyone's, whenever you trigger your smart speaker, it's able to give you better personalized recommendations. And even when you're using grammar assistance inside of your browser, Some of these, or a large variety of these, actually use deep learning based models to help you correct your grammar, to help you correct your context, depending on whatever document you're working on. If you use language translation, or if you've ever been to a foreign nation, Google Translate or similar platforms use deep learning to an extent to be able to efficiently translate one language to the another. Or even on your phone, when you're able to simply point your phone on a image written in a foreign language, you're able to translate it because a deep learning model or a computer vision model with an intersection of NLP. So it's a combination of both. The computer vision algorithm understands the image, and the NLP model converts it, translates it into another language. That is also a model, a deep learning model running on your phone, helping you to translate language in real time. So another few applications of deep learning: in the previous module, we had learned about structured versus unstructured data. The previous two were broadly unstructured data. Images are simply raw pixels. Structured data, we have data that follows a certain formatting. So think time series data or tabular data or recommender systems. We had a few questions or suggestions during the email that you're interested in hearing more about. Where can deep learning or AI be used in healthcare? There's actually one blog on our website that I recommend. It's about how is driverless helping with COVID predictions. So essentially, time series data is being used. Time series, we're predicting using time series data. And any data set that has a component of time in it broadly is known as time series. Even on Wall Street, for many hedge funds, deep learning is useful to some extent. Many quant researchers use deep learning to better create models that use time series components. It's being heavily used in data sets that have transactions in them by banks in different sectors. Or even on your recommender systems, whenever you hop onto Netflix and you're trying to look for an image, you see a curated list that shows a percentage match based on your interests. That is recommender system running in real time, curating content for you. Another interesting application that's being used today to make an impact would be in robotics. So for manufacturing, many of these manufacturing lines, manufacturing pipelines, some parts of it are being automated using robots. I would broadly classify these as large scale robots. So robots that are sometimes larger than a standard human being. These are one form of automation that use some different applications of deep learning combined. So you could have a computer vision algorithm running on the robot that checks for faults in the manufactured object. Or you would need a computer vision model on your robot to understand how to join two parts, for example. Or let's say in a car manufacturing pipeline where you'd want to join the door where it's supposed to be and not under, or not where the hood is supposed to be for a car. For all of these, to some extent, you'd like to use a computer vision system on the robot, assuming you're following that. For self-driving cars, honestly, I've never been inside of a Tesla, but these indeed do run deep neural networks, deep learning models on them to be able to navigate them. Or if you've ever purchased one of those miniature robots that go ahead and clean your home, those indeed deploy these models. So as you can see, deep learning isn't a far-fetched technology. It's not a far-fetched term. Even though it includes some good amount of math in it, there's a lot of jargon in it. It's actually being heavily used today. inside of our homes, inside of industries that are doing physical work. So for part three, I'm going to cover interesting use cases where maybe do a case study of a few or highlight different ones that will help you further cement where deep learning is being used in the industry. So there are different types of computer vision problems. I'm going to do a deeper dive into computer vision since I'll also follow up with a demo of how driverless AI does this. So there are different ways of tackling computer vision problems. You could classify your image, which is simply check if your image has a cat or a dog in it. You could do pixel level understanding of it. So as I had shown in the self-driving car video, if for some reason you'd like to understand every pixel inside of an image, that is known as segmentation. If you'd also like to localize objects, so for example, when you're trying to take a selfie and you'd like your face to be the highlight of the photo, you can actually already see a box being drawn around your face. So your camera, your smartphone camera is actually trying to localize your face inside of the photo. That's localization. If you're trying to do object detection, essentially how many different objects are there inside of a photo, that is broadly known as object detection. Or if you're trying to separate these out inside of the image, for example, if you'd like to pull our cute doggy's picture out of this image, you're segmenting the instance of this particular doggo from this image. This is different from classification in the sense that there are multiple objects, or this is different from semantic segmentation in the sense that it segments every individual instance present inside of an image. Now, just to recap, just to remind you, this is a gentle introduction to some jargon so that you'll have a better understanding when we come around to explaining these. But broadly, more or less, you could talk about computer vision problems across these few buckets. So you might be tempted to ask, where exactly is this being used? Where would you even want to deploy a technology that's being used to segment dogs as an example in the real world? So in healthcare, X-ray images are one of the primary images that many practitioners work with. And computer vision is actually very helpful to a lot of practitioners in not replacing their efforts, but essentially helping them speed it up. So you could use computer vision to better understand what's inside of an image, or as in helper tool. Remember, all of these machine learning tools, all of these deep learning tools that we're talking about are essentially helper tools. So just as an helper tool to help you better understand what's inside of an X-ray, or on a manufacturing line, if you'd like to detect defects for quality control. So even before your product goes out and you have to deal with the customer support team. So instead of having customer support, why not have a better quality assurance? So for physical products, for defect detection in metals or different manufactured products, plastics, etc., you could simply have computer vision running on your manufacturing line to understand if there are any defects on any surfaces that you are producing. In retail, you could try and understand who's purchasing, at what time are they purchasing, keep a track of your inventory. And essentially, whenever you at least go online to surf, you can see better recommendations. You can see what to purchase. People who bought chai would also be recommended a mug along with it. It's also being used in insurance. This has been covered in a previous lecture, so I'll skip this. In agriculture, to understand how your crops are growing, to understand how well is the produce doing, to sort it so that you can physically sort the produce and sell the better batch to a better market, essentially maximize your gains from it. All of these applications, all of these industrial use cases to some extent do use computer vision in today's world. So I'll come back and run a driverless AI demo very soon, but I'd like to talk about NLP first because I'll also show a small demo along those lines. NLP stands for natural language processing. And as you can imagine, this is not distinct, this is not separate from computer vision. There's a lot of overlap. As I had mentioned, even for apps that translate photos on your phone, NLP works in parallel with computer vision. It works together with computer vision. So not all of these applications are exclusive. There's a good amount of overlap. These may or may not use deep learning completely, but some part of them do use it. So if you're an e-commerce retail website, a large part of your business would depend on how good are you rated on a platform. And you want to understand what your customers are saying so that you can help them better. You can iterate on your efforts. If you're a large scale company, you might be getting a lot of reviews. So you'd like to use NLP, you'd like to use deep learning broadly speaking, since deep learning produces the best results. The reason you'd prefer using deep learning across any of these use cases that I'm talking about to remind you is because deep learning achieves a much higher accuracy compared to traditional algorithms. So of course you could use simpler algorithms as well, but deep learning allows you to better understand these, to understand context with a higher accuracy and essentially help you produce better results. So you'd like to understand if someone is positive about a product you're putting out, maybe they're neutral, or drill down on the people, find out who's unhappy about it, see what you can do, iterate upon it, put out a better one. Deep learning recently has also shown a few interesting examples of creative AI. A simpler one would be generating product descriptions. So for higher rankings across search engines, you'd like your text to be better written, and you could generate text using NLP models. For another interesting one, I'm going to pause my presentation, hop off to another interesting GIF that I found on Twitter. So what this demo by Sharif Shameen is showing is essentially they've created a demo and they've put in a requirement about code they need to generate for their newsletter. And as you can see, just simply typing in a button for every color of the rainbow, the model will chuck out code for a button for every single color of the rainbow. And you can take this and put it on your website. So this may not be creative in the sense that we're using deep learning to write code for us. But to me, this is pretty mind-blowing that you can simply give your requirements in simple English and have the model. This is a transformer model. This is an NLP model, so to speak, generate code that you can simply copy and put on your website, essentially lowering the barriers, and as a tool, really lowering the barriers for how accessible tech is for everyone. So I'll now go ahead and do a small demo of how you can use these inside of driverless AI. Okay, I hope everyone can see driverless AI running. Franklin, maybe you can confirm.
Yes, I can see it.
Great. So this is driverless AI H2O.ai's flagship product, and I'm going to show you how to run image models or how to do image experiments inside of this. Now this is the datasets page of the platform of the software. What I've done is I've loaded up a lot of datasets. Essentially, I've been working on these for a few days, so you can see all of my datasets loaded up here. The particular one I'm interested in today is cat, dog, mouse. It contains images of cats, dogs, and mice. So let's, and you can essentially upload any image to here. You can connect it with a S3 bucket if you'd like to. I have already uploaded this, so I'm gonna quickly run one of these. And our goal is to create a good model that's able to separate between images of cats, dogs, or mice. So as soon as I load up the dataset, driver list prompts me to select the target column. I'm not interested in predicting images. I'm interested in predicting the label of a shown image. So I'm going to select that. And as soon as I do that, it launches into what I call the Iron Man dashboard. You can already see a lot of settings being flashed at you. There are three knobs using which you can select how much time, how much interpretability or accuracy would you like driverless to focus on for this model. Note that these aren't directly connected to the numbers. So this isn't essentially going to produce a 70% accurate model, but it'll essentially create different proportions, or it'll focus as much on different components depending on howsoever you select the tile. So as I increase the time, you can see that the different experiments I'll run changes. So if I go up all the way to 10 for time, this might take a little more while to run, but driverless will run more experiments. And this is essentially an auto ML platform, automated machine learning platform. And this does not mean that it is there to replace your machine learning pipeline, but it's another tool for you. By which I mean, if you're a data scientist, you can also go into the settings. I'm going to navigate to image inside of expert settings because we're running an image model. And you can essentially change all of the settings. You can select or deselect whatever models you want to run. So these are different deep learning models inside of driverless that you can run for your use case. Let's say I'm going to select all of them because I know that given for my problem as a domain expert of creating classification between dogs, mice, and cats, I know all of these models are useful. I'm going to leave TensorFlow models on auto, and I'm going to save this. Now there are two options that you can follow here. You could launch an experiment, which will essentially trigger an experiment that'll keep running. Or another feature that I really like is you could create a leaderboard, which will create a queue of different experiments. So if I navigate to this tab where I've already done that in advance, what happens is different experiments are run, and you get a leaderboard with different validation accuracy so that you can compare ahead of time of how your models are going to perform. I'm not going to do that. I'm just going to launch an experiment. As soon as you do that, the experiment starts to run. And this might take a little while because I've selected the time to run for full extent. And with time, you'll start seeing your validation data details, your variable importance details. So essentially, deep learning is a way of learning feature representation. And you would want to create different features. You would like to do feature engineering. So with time, you'll see the importance of these. So essentially, it's not a black box model. You keep getting insights of what's happening behind the scenes, what's running behind the scenes. Now, this might take a little while, so I'm going to navigate over to another experiment that I had run ahead of time. Once this is completed, you get a overview of all of the experiments that were run. If I hover over any single one of them, I can see that these are the different models that were run. So a few models for exception. This is one of the deep learning models for computer vision was run. I can see the variable importance for all of these. And towards the right, I can also see what happened inside of the experiment, what settings was it run on, and my system specs, which is a single GPU machine. If you'd like to take this model and deploy it, you could also simply download or build a Mojo scoring pipeline, which is a Java jar file. So essentially, you don't need Python to deploy this. Essentially, you could simply take this and put it on a server, run predictions. Now, the reason I'm showing this is as an example to how easy it can be depending on what software or what tool you're using to do any of these applications. I'm going to show another one where I had done another experiment for um, musical instrument reviews. So here's the data set that I had loaded up. Essentially a similar pipeline. I need to select the target column. So I know by analysis that this data has ratings in the overall column. So using NLP, we'd like to predict the reviews and ratings of this. And this might be useful for if you're trying to see new product lines. Again, a similar setting here. I might want to play around with some NLP settings here. For now, let's leave them as they are. Once you're happy enough, you click launch experiments. You understand your pipeline, you see what comes out of it. And once that is done, you can take the result, simply download it as a Java file and put it on a server if you'd like to do so. So these are two of simple demos that I wanted to show during this presentation. I'll definitely be doing a deeper dive during the weekend. So if you'd like to join the AMA sections, I'll do another demo, and I'm happy to talk about the details of what happens behind the scenes. But just to remind you, this is to show you how easy it is to get started with all of these techniques to even create state-of-the-art models. I'll share an internal secret. The image models that are being generated in the background are good enough to win you medals, even gold medals on Kaggle competitions. So the tools for deep learning are creating a very low barrier for entry. And depending on which ones you use, you can easily get started across different applications. Another one that I'd like to talk about is recommender systems. Now, coming back to what we were talking about is, where is deep learning even being used inside of the industry? Is anyone even using deep learning at all? If you look at the images, this is from LinkedIn. This is literally my LinkedIn profile. I opened it in incognito. And a few of my colleagues are being shown as people you may also want to connect with. So through some machine learning or through some model that's running on the website, I'm not aware of the details, you being recommended people based on my interest or based on my interactions on the platform. If you look on the image underneath it, this is simply our Grandmaster panel that I was watching this morning. Would highly recommend watching any of these if you have some time on your hands. YouTube or different websites like Netflix automatically curate content based on what you're watching and what your interests are. So as you can see, the first video being recommended is another amazing video from our channel, which is Feature Engineering with H2. This is a presentation by Grandmaster Dimitri Larko. I watched it and I wasn't disappointed by the recommendation. I did end up wasting a lot of hours in the morning, but that speaks to how good these models were. And depending on which platform you are on, you also get a list of who to follow. You may also like, these are also being surfaced based on recommender systems. So to talk a little about why is deep learning important today and what has happened in the recent days that it's important, I'd like to ask the audience a question. Let me open up the chat. When do you think the first algorithm or the first paper for deep learning would have surfaced? Would anyone like to take a guess at it? Okay, I don't see any answer, so I'm going to give a spoiler. The first paper for perceptron, the single ANN model, someone has mentioned 2008. No, you're wrong. In 1958, yes, 1958 was the time when the first paper for perceptron had come out, which is essentially one of the foundations of what we build on today. In 1966, MIT, Marvin Minsky at MIT put out a letter to his undergraduate students that, hey, let's sit down this summer and solve vision. We could take a camera, we could use some algorithms and understand what's going on. And that was one of the ambitious efforts, if I may, that led to the creation of C-Cell library at C-Cell laboratory, apologies, at MIT. In 1997, IBM had created Deep Blue to create an AI, broadly speaking, that solves chess. And this was based on the perceptron algorithm. Followed by that, there was a phase of quote unquote AI winters where we didn't see any growth in deep learning, where we didn't see any action in deep learning in the industry, so to speak. And in late 2000s, what happened was there was a surge of data, there was an upsurge of data. Everyone got access to the internet. Digital data increased a lot. And thanks to us gamers, yes, I'm one of them, GPUs got cheaper and better. Why are GPUs important, you may ask? Deep learning, if you remember, from the jargon section, is a collection of matrix operations, and these run faster on GPUs. So as GPUs got cheaper, you could run more experiments, and there was more deep learning research. In 2000, I believe this was around 2005, and by 2012, Stanley from Stanford had completed 30,000 miles of self-driving. And another one of the major breakthroughs in 2012, there used to be this competition known as ImageNet based on the famous ImageNet data set. In 2012, AlexNet, which was one of the first deep neural networks to win the competition successfully, had shown a huge improvement in accuracy. So it was safe to say by this time, deep learning got very interesting in early 2010s. But that wasn't enough. That wasn't just the few examples. In 2015, deep learning based language translation models started to appear. Many online translation services switched to deep learning and showed much better results. Go is one of the arguably most respected games and most difficult games that humans have created. In 2016, AlphaGo became the first computer program to defeat one of the best Go players, who was arguably one of the strongest Go player in history. In 2017, driverless AI was born. And in 2018, OpenAI 5 showed that humans actually lost to AI in computer games, as well, as sad as that sounds. Fortunately enough, it's not yet happened across all of the games, at least the games that I've played in. So we might have a few years, at least for us rebels, but it has been shown that even for complex games involving different strategies, involving teamwork, deep learning based models, deep learning models that involve reinforcement learning are better than humans at playing the games. Now, to summarize quickly and give you a teaser of what's coming up next. So this session was more of an high level overview of what even is deep learning, why should you care, is it even being used anywhere, if yes, where is it being used, is that just across a single industry, what different divisions and respective applications of deep learning exist today. And I tried to cover a few interesting use cases based on these. Now, to talk about upcoming sessions, the session that will happen on Thursday, there'll be a live recording that will be posted later. This will talk about a few different algorithms inside of deep learning and the recent developments. And if you'd like to talk more about the demos that I've shown, I'll be running a few more demos over the weekend. You're more than welcome to join the Ask Me Anything session. We've had very interesting discussions over the weekend. And the next module, which will start next week, will be about AI and big data. And as a reminder, please don't forget to complete the quizzes if you'd like to get a badge for this module. These should be up as well once this module is concluded. Please remember to attempt those, and you're welcome to ask any questions in the AMA section, in the AMA sessions if you'd like to. And I think we have some time left, so I'm happy to take any questions if there are any. Okay, I don't see any questions yet. So what I'm going to do is point you to a few resources. If you're interested, you can check these out and further read a bit more about the things that I've already mentioned. You can check out our glossary that's up on our website. A few of the examples that I've quoted are up on a blog post. So if you literally search computer vision or natural language processing on our website, you should be able to find these. And these are two more interesting articles that I didn't cover in depth on this lecture. So I see a few questions around if I could provide some information on recommender systems. I'd recommend checking out the blog post. Driverless AI can help you choose what you consume next. And yes, driverless does do recommender systems. This blog post covers a bit more about it. But essentially, whenever you being recommended content, products, entertainment, or anything on the internet, wherever a human is not involved, so where you don't have a salesperson talking to you, it's essentially to some degree being done through recommender system. And a good amount of these now use deep learning inside of them. How is recommender system treated as structured data? By structured data, I was referring to tabular data. So whenever you have a recommender system, you'll have tabular data ideally about your customers. So your data set about your customers, where they would have rated a few products, you would have an understanding of, let's say, what movies do they watch, how much they have rated that. And based on that, you can use the model to suggest new users what movies they might enjoy based on similar likes. So that's a very simplified overview of the same. We have a few more minutes. I'm happy to take any questions if anyone has a few questions. Okay, great. Thank you everyone for joining. This was a very brief overview. I'm going to be doing deeper dives over the weekend. And if you're watching a live recording, the sessions will continue running. So even if you join at a later time, I'm happy to talk about deep learning. It's one of the things that excites me the most. I hope you enjoyed this session. And on Thursday, or if you're watching the recap in the next video, you'll learn more about different algorithms behind deep learning and the recent developments in the field. Thanks for joining today.